Hi everyone, Kurt with Hypnodyne again. Yesterday, I uploaded a video in which I presented a way to collect the movement information on a per second basis. And today, I went a little bit further and I incorporated that into a somewhat more robust uh, algorithm that detects both the proximity to REM sleep as well as the movement. The way this is supposed to work, and I'm going to show you the results first. This is the scoring software, HD Scorer, and this is a display that comes from a marker file. To import a marker file, just go to Import Markers. The marker file is just a text file. And so what we're seeing here, the colors in purple are the epochs in which REM was detected. And the way that's output, it's from here. No, sorry, where is that? Epochs. Okay, so here, whenever there's a REM epoch, it creates a purple marker. So we're seeing that in purple. The first thing you should pay attention to, of course, is the sheer and utter accuracy of this REM detection. There are no false positives whatsoever, and a substantial portion of actual REM sleep is tagged in purple. But now, on top of that, what I'm doing is analyzing the movement on a second-by-second basis, and that's shown here in green. So you see here, they got tagged as a movement because of this movement there. If we go towards this middle of this sleep cycle, we've got this movement right here, and here we got all this movement, right? But now in yellow, we have an overlap between both having a movement and also being in the proximity. Of course, that is defined in code, and I define it as being within 5 minutes. But all the movements that are within 5 minutes of a preceding REM epoch are in yellow. So these are periods in which not only are you dreaming, but you're also having an arousal during a period of REM sleep. Now, if you look at the distribution of these yellow things, they normally occur far before the subsequent onset of, again, N2 sleep. This one being the only possible exception. All the other yellows are really sandwiched in between other REM epochs. So the idea here is to give an audio stimulation, not during common REM sleep, in which, as we know, the auditory pathways are blocked, but during periods of an actual arousal, when, for example, here you can see from the order of the accelerometer traces that there was a change in position. You can also see it with the head here, although I think the degree of transparency is a little bit excessive, but you can see this was a change in position all the way from facing to the right to facing to the left. So this is an ideal stimulation point where you're probably awake, but you're going to fall back asleep really easily and quickly, and you are in a long REM sleep chunk. In fact, you begin dreaming again. Let's see how long after the audio stimulation you begin dreaming again. 1 minute, 1 minute and a half. I think these might already be eye movements. 2 minutes, very strong eye movements begin again. So you have 2 minutes from the stimulation and you're already pretty much drowsy and having slow eye movements. And yeah, you have 2 minutes until, again, falling back into REM sleep. My idea is that by doing this, you're going to be able to actually have incorporation of auditory messages during sleep. Now, as a test, I just have attention. You might be dreaming, but you can easily put anything you want here if you want to set some dream scene. All rests on that being incorporated in some way. I must say that the word incorporation isn't even right, because you use that when you're in a dream, and here you're technically awake in between dream epochs. So it's not even incorporation, but that's a good thing, because it means there's much higher chances of it passing through to the dreaming mind. Now, to do this, it was really easy. I just defined two counters for what second we're at. This is just a number that increases as the seconds pass. And this is the last REM second, so I'm keeping track of how many seconds passed since the last REM epoch detection. This is nothing, it's just to show that the script has started. I create the text file with its header. This is copied verbatim from the custom markers example. So it's just something you would cut and paste. The rest, I didn't change anything in the buttons. I could perhaps change the function of a button and give it another countdown so that if you're getting a stimulation and you actually don't want to be bothered for half an hour, you could easily use the button. But that aside, the way this is done is, first of all, I delay any stimulation for 3 hours from the beginning of the recording. That's why you don't see anything here. In the beginning, you're trying to fall asleep, so you don't want to be bothered. So wait 3 hours. Then if the movement exceeds a certain threshold, and also if you're at least 5 minutes if you're less than 5 minutes from a preceding REM detection, that is one of the purple tags, then it's both going to append the marker with the audio trigger, in yellow, and also it's going to play the audio stimulus. Otherwise, it just adds the tag in green. And that's it. And I only added another line to here to keep track of the REM. So literally this, and these few lines right here is all it takes to realize this kind of algorithm, which I believe is pretty powerful. I'm going to include it in the program distribution. So if you download the new version of the software, you will have this JavaScript file under MovementVoice.js. And you can try it for yourself and let me know how it goes. Kurt out.